Alright, so for fun I decided to show you guys like what a regular synchro and like a triple cone look like the difference. Anyway, this is your shift fork, so when you move your gear you like go up and down. And then down is like that's when then normally there's a gear on the other side. And when you go up it's another gear. Okay, so anyway that's the synchro. You can see how it's spinning free. And so anyway, the way a synchro works is, see, it's spinning free. And when pressure gets applied, see, it creates friction. It has the gear kind of match until you can get it into gear like that. It's just when pressure is applied as you're shifting, as it starts putting, the shift fork starts going towards the gear, it creates friction to have the gear or the whole shaft, or no, actually just the gear, catch up in speed or match the speed of this hub, because this hub is part of the shaft, input or output shaft depending on it. And this gear is spinning free, a roller bearing, so it gets everything up to speed. And so it meshes. Now, how does that work? I compare. So you have your selector ring here, and then the way a single cone synchro is. Well, that's a fifth gear. Just give you an example. Here's regular gears. So show you a difference. A single cone synchro looks like this. There are the teeth. See the real, I don't know if you can see it real well. It's hard to get a good, see how the little teeth, grooves I should say, those grooves cut through the oil and dig into this nice smooth surface on the gear. And then, these dog teeth right here where my thumb is, those mesh with the dog teeth on the selector ring, and that's what makes it lock. So this is normal synchro, where it's one synchro ring and one cone on the gear. And that's it, and that's how it works. Now here's a triple cone synchro. So you have one of those cones, just like that. Then you have a smooth surface on one side, a smooth surface on the other. So that the teeth from this gear bite to the outside. The teeth on the outside of this gear bite to the inside of that. And the teeth, so you can see this also, I can't get it to focus. You can see a little bit. But the teeth on the inside of this bite to the cone that has a normal one like this one. So you have one friction point, the outside of the gear. See, because then this has these tabs that go in these holes. And that's how this thing is always the same speed as the gear, whereas the gold ring is going to be, see, it's got three tabs. It's going to connect like that, so that this outside ring and this, the inside gold ring are always the same speed, whereas the gear and this outside metal ring are always the same speed from those other teeth. So yeah, you have the inside of this to that, one friction point, the outside of that ring to the inside of this silver ring, another friction point, so there's two, dual cone. Then you put this on it, the inside of this one, there's triple cone. So a regular dual cone is designed that the gear would actually look like a fifth gear. which would look like this, where there's no cone, and it just has that 4 tabs with a silver ring, and then on each side it essentially pinches it with gold rings. That's what a dual cone looks like. And this is a triple cone. So this is second gear in an MR2 93 plus, or 1, 2, 3.